All right, I'm just going to zoom in on some of these that I see blank and try my best to explain them to you. This first one, I think you have to do what we call factor by grouping. I haven't actually worked these out, so I'm not positive, but the idea is that you kind of like separate these two, and then you take out the greatest common factor of each of these, which would be 8x squared, and if you took out an 8, you'd have 5x plus 4. And then what you're trying to do is you're trying to get a 5x plus 4 over here. And I think if you take out a 5, you get just that, right? So that'd be 5x plus 4, yeah. Perfect. Okay, so now you have these 5x plus 4s. What happens if you were to factor out a 5x plus 4? You'd be left with 8x squared plus 5. It's called factoring by grouping. Let's see, what else you got? 10, they actually want you to factor. It looks like you try to solve it, but what they want you to do is to factor it. So if you took an x out of both of these, you could have x times x cubed minus 1 equals 0. And that's not completely done because there is a factoring, it's called the sum and difference of squares formula that you kind of just need to have memorized. You could use it here. You would also use it on, I think I saw it somewhere else over here. Yeah, you'd also use it on that one. So I'll write that formula for you. I'm just gonna zoom in and write it. You might want to copy it down. It's called the sum and difference of cubes, okay? So I believe I'm just writing this from memory, so I hope I write it right. Anytime you have that, a perfect cubed plus or minus perfect cube, you get the acronym to remember the symbols is SOAP. So a plus b, a squared, and it's the opposite sign. So if it was a plus, it's a minus, and if it was a minus, it's a plus. And then it's just a times b, and then it's always positive. That's what the AP stands for. The O stands for opposite, S stands for the same, and then this is b squared. So if you can always factor in that pattern, then you could break down anytime you have a sum or a difference of cubes, which is what we have right here. That's a difference of cubes. So we could think of this as x times, your a would be x and your b would just be 1, because 1 is the same thing as 1 cubed. So I'm going to say the same sign as x minus 1. Then it's going to be x squared, then it's going to be the opposite sign. It's going to be 1 times x, which is x, and then always positive. And then the b term, which is 1 squared is still just 1. And now you set that equal to 0. And you got all your solutions here you'd be able to solve. Right, you get x equals 0. You get x equals 1. And I believe this is no solution. Yeah, I don't know. I'm pretty sure this is no solution. I haven't done it in a while. You could plug that in a quadratic formula and see if it's no solution. Okay. What else we got here? Yeah, I think this one, this number 12, is going to be like this. We have to factor by grouping. The other one I saw that you need to do, I'll do number 16, and the strategy with 16 is very similar to 15. So with 16, you need to think of these as 2 separate problems for now, and we need to get common denominators to simplify this. So the first thing I would do is multiply this by 2 over 2. And then down here, same thing, I would multiply by 2 over 2. Because if I do that, let's just look at the top. Now I would have 10 minus a over the common denominator of 4. And then down here, I would have 2a squared. I want to do it in blue, but oh well. 2a squared plus a squared over now a common denominator of 16. Okay, now it's a little bit better because at least now we don't have 4 fractions. Now we just have 2 fractions inside of a fraction instead of 4 fractions inside of a fraction. So now what do? Now what we do is we say, can we simplify this further? And remember, this is like the main division bar. And so anytime you have a fraction divided by a fraction, you can flip and multiply. So I'm going to bring this up here, but I'm going to do the reciprocal. So 16 would go on top. And by the way, that would be 3a squared on bottom. And we just multiply. And before I even multiply, you take a 4 out of that, make it a 1, take a 4 out of that, make it a 4. So I'm looking at 4 times 10 minus a over 3a squared. That's about as simplified as I think you could get. You could obviously distribute the 4, but I don't know if that makes, I don't think that helps you with anything. Nothing cancels out or simplifies, so I think that's a good answer. Let's see. What else we got here? I sent another video on these ones. This is on completing the square and then getting it. You complete the square and then you have to get it into this format for a circle. I'll zoom in and write this, the format. So the idea is that you use a process to complete the square to get it to fit this form, and then you're able to tell what the center and the radius is. For these ones, what you need to do is kind of just graph it, like graph a line at x equals 15, x equals 7, and then you'll see, well, if there's tangents here, the radius would have to be half that distance, right? Because that would be a diameter, right? 15 to 7 is 8, right? So the diameter would be 8, therefore the radius would be 4, and it would have to be exactly in between these two. So what's that? So the h value would have to be 4. And that says the center lies on the x-axis, so then the k value would be 0. So if you sketch that out, it'll make more sense. Same thing with this. If you sketch this out, you should be able to tell where the center point is, and you should be able to kind of figure out where the radius is over here at number 20. These ones, literally, I think all you need to do, just go Google what is that, because I believe all you have to do is add 2 pi or subtract 2 pi repeatedly until you're in this domain here. I think that's everything. Yeah, see, you did it right here. You factored this one good. I didn't even see that. You got this. Same sign. Opposite sign. Always positive. Yeah, that's right. So you factored that. Maybe these ones up here look like they could be a little messy. Let's play with number 3. So number 3, I would just do a little bit at a time. Like the first thing you could do is it's not really called distributing, but it's like applying this exponent to everything. And if you did that, negative 2 squared is 4. And then you would just have n squared. And m negative 4 to the second power is just m to the negative 8. You just multiply. Down here, let's see, we have a negative times a negative, so that makes a positive. Kind of funny that they put m to the 0, because that's really just like a 1. So really that's just like saying negative 1. So that just becomes m to the 4th and then n cubed. And now what you do is just kind of simplify, but that's a negative 8. So before we start to cancel things out, we would want to rewrite this. And I'd leave the 4n squared up there. And really I could say, like, I could just kind of move this down here to be like multiplying by m to the positive 8, which means this is really m to the 12th n cubed. And then here we could just cancel out 2 n's and cancel out 2 n's here, and we would have 1 n left on the bottom. And so I think the best answer here would be 4 over m12 times n. Is that what you got? Let's see. That looks like what you got. Yeah. Okay, I think that's good.